Hi everyone. Okay, so let's continue with our discussion on partial fractions, and here is a typical problem that you will see in this section. Okay, so we have to integrate this function. Look how complicated it looks. U sub or anything else doesn't work. You see a rational function, you immediately think partial fraction, rational function. Can I break the denominator? Can I have factors in the denominator? If so, then there you go. So this is already factored, as you see. If it wasn't, if it was like x to the 4 plus 2x squared, you pull out x squared, you factor it, and then you go from there. All right. Now, what is one main thing that you have to check? The degrees. Okay, what is the degree of the top? The degree of the numerator is 3, and the degree of the denominator is 2 and 2, so 4, right? And it's strictly less, so we are good to go. Always check that. All right, which means we can just directly start by splitting it up into fractions. We don't have to do long division yet. Okay, so let's start, and let me show you the entire algebra that you have to do first. Okay, so I'll need a lot of space here. So you start with your fraction, 2x cubed minus 2x squared plus 4x plus 2 over x squared and x squared plus 2. Write down the fractions first. Okay, so we have x squared. Again, you can think of it as a quadratic, but it's better if you think as a linear x repeated twice. That's how I'm going to think. And I'm going to write down. So one fraction for x, one fraction for x squared, because it's repeated and it's linear, so I have a b. Remember, you do not put bx plus c, because we already wrote the one term with the x in it, which means this is a linear. So this is also a linear, considered a linear but repeated twice. So you have a b on the top. And then I have a x squared plus 2. You cannot factor that any further. So this is going to be a quadratic factor, which means in the top I will have cx plus d, a linear. It's very important that you write the fractions correctly. Okay, now I have to add them together, all three things together. And remember that I will not think about it. I will just write down the denominator to be exactly the same denominator on the left hand side. So x squared and x squared plus 2. Don't multiply all of them, right? Remember, that's not how we find common denominator. Okay. Question is, do you know how to find the numerator? Okay, here it is. Very simple, okay? So we have a attached to x. When I'm combining, how do we know what to attach with a on the top? Very easy. See the common denominator we have? And a has x already, so you cancel out one of the x from this common denominator. Take out one x. What is remaining? One x going away from x squared. So there is an x and an x squared plus 2. That will be attached to the a. Did you hear what I said? Okay, let's do the next one. The next one is b plus b. So what will attach to b on the top? Well, b already has x squared. So cancel out the x squared. So b will be attached to x squared plus 2, the remaining. Okay. Last one is cx plus d. What will attach to that? Well, cx plus 2 already has x squared plus 2. So cancel that out. X squared remains. That will be attached. That's all. Now, two denominators are equal to each other. Therefore, the numerators will be equal to each other as well. So let's write that down. The numerator on the left-hand side is 2x cubed minus 2x squared plus 4x plus 2. And on the right-hand side, I have this long thing. Now, remember in another example in a different video, I showed you one method of how to find the a and the b by plugging in the x value. Same thing applies here, but look, I have 4, a, b, c, d. I have 4 constants to figure out. It's not going to be that easy if you start plugging in x values, okay? There will be 4 different equations. It will take you forever to solve. So there is another method that I'll show you. It's a very convenient method to figure out the constants, okay? When I have 3 or more constants, I go with this method. Only with the 2 constants, I go with the other method. Otherwise, I wouldn't, okay? So, what I'm going to do is, I'm going to expand this numerator completely, expand it. So, distribute everything through. For example, so I have ax, x squared, so I will have ax cubed. Then ax and a 2, so 2ax. So see what I'm doing is I'm keeping the constants in the front and the x terms after it. Okay, then keep on going, bx squared plus 2b plus cx and x squared, so cx cubed plus dx squared. Okay, do you see the left hand side? I have an x cubed term, x squared term, x term, and a constant term. So that's how I'm going to write my right hand side. I'm going to figure out an x cubed term with, okay, so there are 2 x cubes, right? There is one here, one here. So I'm going to combine them together. So what do I get? I get a plus c. Take the common factor x cubed out and write down the constants. The constants that are attached to the x terms, they're called coefficient. So I'm trying to find the coefficient of the x cubed term. In this case, it is a plus c. Okay, next, I want to do the x square. See the x square coming next, so 1 degree less. So cube, then square, then 1, and then 0. Okay, so x square, where are my x squares? I have 1 here, I have 1 here. Okay, combine them together, I get b plus d. That's x square. Then, do I have x term? That's the degree 1 term. Okay, I have just 1. So write down 2a, and I'm going to put a parenthesis so that you can clearly see what the coefficients are. And then the last one is my constant term. There is no x, that's the constant term. So that's my 2b. On the left, I have very similar looking thing, if you notice. I have an x cubed term with the coefficient of 2. I have an x squared term with the coefficient of -2. X term with the coefficient of 4, and constant term is 2. Guess what I'm going to do? 2 polynomials equal to each other if their coefficients are equal to each other. So I can match the coefficients. So I have equations a plus c, which is the x cube here, and 2 is the x cube here, so a plus c will be equal to 2. Okay, b plus d will be equal to -2. Okay, now look, the x terms are equal. So 2a is equal to 4. Look, from here, right away, I can figure out a is equal to 2. Haha. See how easy that is? And the last one is 2b. 2b will be equal to, the constant term here is 2, and immediately I can find b. b is 1. We got 2 of them, and then using those 2, I can get the other 2. See? Plug in a equals 2, so 2 plus c is equal to 2, which means c is equal to 0. And plug in b equals 1 plus d is equal to -2, so d is equal to -3. I got all my constants that I needed. So this method will be very, very helpful and useful. Please understand it. If you need to go back and look through this method, okay? There will be many problems, you will have to use this one. So now that I have all my constants, what am I going to do with them? Don't forget, I have to integrate this function. So I'm going to integrate now, okay? Well, I don't know how to deal with this huge thing, but I know, well, this can be broken up into 3 simple looking fractions. So I'm going to integrate those fractions instead. So first fraction is a over x. Okay, don't write a, write 2 over x. Okay, next fraction will be b over x squared. b is 1. So 1 over x squared. Sorry, I'm forgetting to write the dx. And then last one is cx plus d. Let's see, c is 0. So the cx goes away. And d is -3. So -3 over, what is it? X squared plus 2. Okay, let's see if we can figure out each one, all right? So 2 over x, 2 comes out, 1 over x, that's ln. That one is easy. Plus, now 1 over x squared, don't say ln of x squared, please. This is x to the -2. right? And use power rule. So x to the negative 1 over negative 1, negative 2 plus 1. Now this last one, negative 3 comes out, and then you will have 1 over x squared plus 2. Do you know what the antiderivative of 1 over x squared plus 2? This is one of those that you should like memorize the formula and apply it. This is arctan, and there's a formula for it. This is 1 over this 2, you have to take the square root of that. 1 over square root of 2, then arctan or tan inverse of x over that same square root of 2. That's what it is. Okay. So here is my answer, right? Let me write down one more time. So 2 ln absolute x. So this is negative 1 over x, right? I'm just flipping x to the minus 1, bringing it in the bottom. And then minus 3 over square root of 2 arctan x over square root of 2 plus c. So these problems are going to be long, but do not get discouraged because of that. It is really fun to work out all this algebra and be able to solve such a difficult looking function. So please, please practice, practice, practice.